The sky over northern Europe was unerringly calm for about 3 seconds. Sunlight glinted off contrails at 20,000 feet, the air thin and grainy, the horizon washed in that pale gray blue that always seemed to promise trouble. The crew of the U.S. bomber had settled into the last quiet stretch of the mission. The pilot, Captain Eli Turner, rested 2 fingers lightly on the yoke. The engineer, Mike Raston, flipped through routine checks, humming a tune nobody else recognized. The gunner, Shorty Knox, was complaining about the cold. For a moment, the world looked predictable, mechanical, alive in all the normal ways war could be. None of them knew they were 5 seconds from a fireball. It began as a flicker on the edge of vision, a small silver dart slicing upward through the haze. Knox leaned forward in his turret, squinting. "Hey, Cap, you seen that?" Turner never had time to answer. The German missile slammed into the right wing just beneath the fuel line, detonating in a flash so bright it washed out the cockpit windows. The explosion wasn't a blast. It was an eruption. A volcanic punch that blew panels open like tinfoil and turned a third of the wing into a sheet of flame. Turner's world went black and orange. The bomber bucked so violently that his headset was ripped off. The whole aircraft rolled right in a sickening dive, screaming as metal sheared away. Warning lights died instantly. Instruments went blind. In the back, Knox was thrown sideways, smashing into the turret frame as a wave of heat burst past him. Raston coughed hard, twisting in his seat as smoke poured through the ducts like the plane had begun inhaling fire. They had all trained for emergencies. None had trained for this. Turner instinctively pulled back on the yoke, but it felt like grabbing a dead weight. The right wing was burning from the inside out, chunks falling away, creating a ragged, twisted outline that no longer resembled anything aerodynamic. The bomber dropped nearly 1,000 feet in seconds. The interphone was dead. The oxygen feed was dead. The radios were dead. Every system that usually stood between dying and surviving had vanished. In any textbook, any simulator, any engineer's model, this moment marked the end. A missile strike at that angle was supposed to sever the wing spar, ignite the fuel tank, collapse the ribs, and tear the aircraft into 3 pieces before the crew even understood what hit them. The explosion should have unzipped the fuselage from nose to tail. Fire should have consumed everything. Gravity should have finished whatever fire didn't, but the aircraft didn't come apart. Somewhere inside the broken wing structure, buried under twisted aluminum and dissolving paint, a sliver of the main spar held. A tiny, stubborn arc of metal. Not by design, not by calculation, not by luck so much as sheer cosmic mischief refused to snap. And because it didn't snap, the wing didn't shear off. And because the wing didn't shear off, Turner still had just enough control to force the bomber out of its death roll. Barely upright, barely flying, but alive. Smoke filled the cockpit. Fire trailed behind them in a long, boiling tail, visible for miles. Turner wiped his eyes with a shaking hand and forced his voice to steady. "Crew, if you can hear me, we're not done yet." They weren't supposed to be alive. But they were. And that meant the fight had just begun. For decades, every air force in the world operated under one unquestioned belief. If a missile hit your aircraft, you were already dead. Pilots joked grimly that you wouldn't even get time to say a prayer. In training films, instructors described missile impacts as mathematical endpoints. Once the warhead detonated, the equation for survival collapsed instantly. The Luftwaffe in particular built its mid-war doctrine around this assumption. There are 4M rockets, air-to-air fragmentation rounds, and high-velocity air weapons were designed around a single goal: obliterate an aircraft structure before the crew could react. The logic was simple. Aircraft were made of aluminum skins stretched over ribs and spars. Missiles carried high explosive charges wrapped in steel fragments. Put the two together and survival wasn't just unlikely. It was considered physically impossible. A direct or near-direct hit meant the spar would fail, aerodynamic forces would tear the wing free, and the entire airframe would collapse like a crushed soda can. Engineers used to say, "It's never one thing that kills a plane. It's everything happening at once." And that was true. Fire, detonation, shock load, torque stress, asymmetric lift, hydraulic rupture, oxygen line flashover. Any one of these could be fatal. Together, they were absolute. Crews knew this. They lived with it every mission. They saw what happened to planes hit by rockets. Wings disintegrated before their eyes, leaving only smoke and falling debris. Debriefers rarely even asked how a missile kill occurred. The answer was always the same. It hit. Case closed. If the missile detonated properly, the human element didn't matter anymore. That's why Turner's crew was supposed to be gone the instant the explosion bloomed across their wing. To the Germans watching from below, the fireball looked textbook: a bright flash, a burst of fragments, and a bomber corkscrewing downward. Luftwaffe ground observers didn't even bother tracking it. They wrote the kill into their logs and shifted their attention to the next radar contact moving across the scope. From their perspective, the laws of physics had already done the job. And they weren't alone in that certainty. U.S. air doctrine taught the same lesson. Manuals spelled it out in stark terms. Aircraft struck by direct missile fire are not recoverable. Pilots were even advised not to attempt heroics. They were told to focus on ditching or bailing out if any structure looked compromised. Surviving a hit was not part of the design. Designers didn't build for it. Mechanics didn't plan for it. No one rehearsed it. That's what made Turner's situation so surreal. He wasn't just fighting a crippled airplane. He was flying directly against what every expert, every engineer, every tactician believed was possible. The moment the missile hit, his entire world and every assumption the war relied on should have ended. Instead, the bomber kept flying, and he was left with the one thing air doctrine never prepared him for: time. Time to think. Time to react. Time to try the unthinkable. Inside the cockpit, Turner could feel this contradiction in every trembling movement of the yoke. Every instinct told him the aircraft should already be dead. Every vibration said the wing was on the edge of tearing off. Every shudder warned him the next second could be their last. But nothing in the controls said give up. Doctrines break. Beliefs shatter. And sometimes when the math says you're finished, the universe offers you one absurd, impossible chance to prove the math wrong. The bomber that refused to die was never designed to be a miracle machine. It wasn't a fortress of steel like the P-47. It wasn't packed with armor or redundant systems like the later war giants. It was a mid-war workhorse, reliable, sturdy enough for its mission, but vulnerable in all the ways engineers quietly acknowledged. A single lucky shot could take out hydraulics. A glancing fragment could sever oxygen lines. And a missile strike that wasn't survivable under any checklist. To understand why its survival stunned the engineering world, you have to start with how ordinary the airframe really was. Its ribs were standard alloy. Its wing spars were strong, but not overbuilt. The fuselage used the same rivet patterns as dozens of other aircraft rolling off the line every day. Nothing about it screamed indestructible. It was a machine built for predictable stresses, lift, drag, turbulence, recoil, not a weaponized explosion tearing into its structure at hundreds of miles an hour. The crew matched the plane's simplicity. Captain Eli Turner wasn't a legend. He wasn't an ace. He was known for steady hands and stubborn focus. The kind of pilot who didn't get himself killed by doing something stupid. The flight engineer, Mike Erston, was the opposite. A tinkerer who treated the aircraft like a puzzle box, always poking around, tightening bolts nobody asked him to tighten. "One day you're going to fix something that ain't broken," Turner used to tease him. Erston would grin and say, "Or fix it before it breaks." The rest of the crew filled the usual roles. Radio man, navigator, dorsal gunner, tail gunner, men who had flown together long enough to develop habits and rituals. Knox the gunner carried a lucky wrench. The navigator swore coffee made him a better mathematician. Turner tapped the compass 3 times before every takeoff. They were normal flyers in every way, laughing about mechanical quirks, arguing about rations, telling the same stories every mission because repetition made fear manageable. None of them thought their plane was special. If anything, they joked about how temperamental it was. The right engine always ran a little hot. The oxygen system had required a dozen patches. The electrical panels sometimes flickered when they hit rough air. They flew through the quirks because every plane had them. And because no aircraft in the war was ever truly perfect outside the factory floor. That's the irony. The bomber that survived a missile hit wasn't exceptional. It was average. And that made its survival even harder to explain. Engineers later combed through the wreckage, expecting to find some secret reinforcement, a manufacturing defect that acted like armor, a misaligned weld that happened to strengthen a critical joint. But in the end, they found nothing extraordinary, no hidden heroism in the metal, nothing built by design to withstand the inferno that ripped through it. What they didn't know was that the plane's fate would hinge not on engineering, but on a series of human decisions. Small, mundane, almost accidental choices made long before the missile struck. A mechanic's adjustment here, a repair patch there, a cable replaced at just the right moment. None of it enough to matter on its own. But combined, those tiny changes created a chain of survival no blueprint had ever anticipated. The plane wasn't meant to survive. That's what makes the rest of the story so unbelievable. Every investigation into the crew's survival started with a single brutal truth. According to the math, the bomber should have disintegrated less than a second after the missile struck. Not crippled, not damaged, disintegrated. The numbers were that unforgiving. A mid-war German air-to-air missile produced a blast wave of roughly 1,500 meters/s. Its fragmentation sleeved throughout hundreds of high-velocity steel shards fast enough to slice through aluminum like wet paper. At the angle Turner's aircraft was hit, the explosion should have cut straight across the primary wing spar, the backbone of the plane, with pressures exceeding anything this structure was ever rated to absorb. Engineers computed it later. The spar should have failed at 0.07 seconds after impact. The wing should have torn away at 0.11 seconds. Aerodynamic load at their altitude should have ripped the remaining structure apart by 0.16 seconds. And by 0.25 seconds, the bomber should have been nothing but fire, fragments, and vaporized aluminum drifting downward. Fire added another layer of certainty. Aviation fuel burns upward and inward when ignited at speed, funneling flame directly into the wing cavity. The oxygen-rich environment at their altitude accelerates combustion, turning a small breach into a rolling inferno. Tests showed that a fuel-fed fire inside a wing at 250 miles per hour reaches structural failure temperatures in under 5 seconds. In other words, even if the plane somehow resisted the shock load of the explosion, which it shouldn't have, the fire that followed should have cooked the wing from the inside until it collapsed entirely. Hydraulics painted an equally hopeless picture. The explosion severed two major lines instantly. Fluid pressure in the remaining system dropped below functional thresholds in under a minute. Without hydraulics, the ailerons and elevators should have been dead weight. A plane without control surfaces at altitude is effectively a falling object. Engineers estimated Turner had control authority of less than 12%. Not enough to keep the aircraft level under normal conditions, much less while one wing burned open. And then there was airflow. At high speed, air doesn't caress a damaged structure. It attacks it. Every missing panel increases turbulence. Every exposed rib becomes a drag generator. A wing that loses its smooth surface stops producing predictable lift and starts producing chaos. Normally, that chaos tears the aircraft into asymmetrical forces that throw it into an unrecoverable roll. Turner's bomber should have entered that exact death spiral permanently. No pilot skill in the world was supposed to override that aerodynamic reality. But the most persuasive number, the one that convinced every engineer this survival was impossible, was the probability assessment. They ran the scenario through models again and again. With every known variable plugged in, the survival odds came back as 1 in several million. Not improbable, not unlikely, essentially non-existent. Everything physics predicted should have ended the plane's existence in a quarter of a second. Everything the crew experienced should have been their final moment. And yet the bomber stayed in the sky. That contradiction, the numbers saying dead, the machine saying not yet, is what transformed this incident from a wartime anecdote into a case study. Something in that damaged aircraft broke the math just enough for life to continue. Something about the explosion, the angle, the airflow, the structure, the crew's actions, or the imperfect nature of real machines created a narrow, invisible doorway through which Turner and his men slipped. Engineers would spend months trying to find that doorway. But in the moment, all Turner knew was simple. The math said they were finished. His senses said the aircraft was dying. And the fact they were still flying meant one thing. Somehow, against every calculation, the fight was still on. When Turner's bomber finally skidded to a halt on the runway, the fire crews charged forward, expecting to pull bodies from a collapsing furnace. Instead, they found a machine that looked like it had already died midair, and simply hadn't realized it yet. The left wing sagged nearly a foot lower than the right, held together by nothing more than warped metal and luck. The first engineer who walked up to the cratered fuselage whispered the only thing that made sense. "There's no way this thing flew." He wasn't exaggerating. Once the fires were fully out, the maintenance teams got their first real look inside the damage. And what they found pushed every textbook they'd ever read off the table. The main wing spar, supposedly the strongest element of the entire aircraft, wasn't just cracked. It was peeled open like a rib cage. The explosion had turned a solid beam of alloy into a twisted crescent, leaving barely an inch of metal still connected. By every structural rule, that wing should have folded backward moments after ignition. Instead, the deformation had created a strange unplanned reinforcement, a compression arc that redistributed load just enough to keep the wing from tearing off. Further in, where the fuel tanks had ruptured, they found something even stranger. Burn patterns that didn't match the way aviation fuel normally behaves. The explosion had sucked so much oxygen out of the cavity in the first instant that the fire burned cold for nearly 2 seconds, long enough for the worst of the structural damage to finish before the real inferno started. That microscopic delay, invisible to the crew, had kept the wing from melting through. Then they reached the hydraulics. 2 lines were shredded. One was gone entirely. Yet somehow a single backup line, never intended to carry full operational load, had swollen instead of bursting. Pressure indicators showed it had run nearly 60% over safe limits. The chief mechanic stared at it for a long time before deciding the war had officially entered a stage where machines were defying their own blueprints. The control rods told another story. Shrapnel had severed one of the primary elevator rods, meaning Turner had been flying with only partial pitch authority. But the secondary rod, bent like a corkscrew, had jammed itself into a perfectly braced position, effectively turning the damaged system into a crude but stable hybrid. It wasn't supposed to work. It shouldn't have worked. Yet, it gave Turner just enough pitch control to keep the aircraft from dropping into a death spiral. The airflow evidence stunned the most. Along the leading edge, dozens of impact points formed a chaotic lattice of holes, dents, and blowouts. But strangely, the damage created a semi-uniform pattern of microturbulence that actually smoothed some air flow over the surviving section of the wing. It was like the explosion had carved an accidental aerodynamic bandage. Sloppy, ugly, and scientifically absurd, but undeniably effective. And then the team found the final clue, the angle of the blast. High-speed analysis revealed the missile had struck at a shallow offset instead of a direct perpendicular hit. That slight variation on maybe 3 or 4 degrees turned what should have been a shearing decapitation of the wing into a glancing shredding wound. That single deviation had made the difference between instant death and a fighting chance. By the time they were done, the engineering teams concluded something no one expected. Turner's survival wasn't the result of one miracle, but a stack of tiny improbable mechanical behaviors that aligned for a few impossible minutes. A cracked spar that bent the right way. A cold burn delay, a jammed rod, a lucky hydraulic swell, and a blast angle just beyond the fatal threshold. Not a miracle, they said. A cascade of near 0% outcomes that somehow struck in perfect sequence. Most pilots, even veterans, react to a sudden explosion by freezing for a fraction of a second, just long enough for the aircraft to make the decision for them. Turner didn't freeze. The moment the missile hit, he shoved the throttles forward out of pure instinct. That one action countered the asymmetric drag from the shredded wing before it could flip the bomber inverted. He didn't know the spar was half gone. He didn't know the elevator system was hanging together by a twisted rod. He just knew that the plane was trying to roll left, and he wasn't going to let it. The cockpit was a sauna of smoke, burning insulation, and alarms screaming over one another. Turner couldn't read half the gauges, and the other half were lying to him. But he understood the vibration of his aircraft better than any instrument. When the left wing trembled, he nudged the right rudder. When the tail shook from the failing hydraulics, he eased off the yoke instead of fighting it. He flew the crippled bomber the same way a rancher handles a wounded horse, gently when it resisted, firmly when it panicked. Every textbook said a damaged craft should be leveled first, stabilized second, and redirected third. Turner did all three at once. He banked shallow instead of steep, not because it was standard procedure, but because he sensed the wing would shear if he pushed harder. He reduced airspeed by the smallest margin possible. Any slower and he'd stall. Any faster and the damaged wing would tear like paper. Somehow, he found the razor-thin corridor that almost no pilot could stay inside, and held it for more than 20 minutes. Survival wasn't just a matter of control. It was judgment. When the crippled elevator began to vibrate violently, Turner didn't fight it the way most pilots would. Instead, he let the tail breathe, allowing the force to dissipate in micro-oscillations that prevented the rod from snapping. That wasn't training. That was a feel for machines that only thousands of hours in the air, and a mechanical intuition bordering on impossible could produce. Then, there was the descent. Approaching the airfield, Turner realized landing gear deployment would overstress the remaining hydraulics. So, he made a call that shocked even the most seasoned engineers. He landed wheels up on a burning aircraft, with a failing wing at a speed specifically chosen to distribute impact force along the strongest surviving sections of the fuselage. Too slow and the bomber would cartwheel. Too fast and the wing would shear, flipping the aircraft into a ground fireball. Turner picked a speed so precise that the measurement team later said it was within 3 mahar of the safest possible number. What truly set him apart wasn't reflex, strength, or training. It was the way he treated the plane not as a machine, but as a living thing fighting alongside him. Turner didn't wrestle the bomber to safety. He coaxed it there. He understood what parts of the airframe could take stress, and which ones were whispering their last warning. Where most pilots would have over-controlled and ripped the plane apart in seconds, Turner matched the wounded aircraft's rhythm, guiding it like a partner through its final breaths. When he finally slid to a stop on the runway, the bomber wasn't just a wreck. It was a carcass. And yet, Turner had coaxed that dying machine through storm winds, burning metal, missing controls, and physics itself to bring his crew home alive. Inside the fuselage, the crew lived a different kind of nightmare. One that had no instruments, no windows, and no control over anything except their own fear. The missile blast had plunged the aircraft's interior into a hellish cavern of sparks, smoke, and shrapnel that rattled like coins inside a metal drum. Men couldn't see more than a few feet. The intercom was dead. The heat was so intense that the ammunition belts along the wall began to smoke, and for a moment, every man on board wondered if they were about to cook alive in their own bomber. The first instinct was to bail out, but the explosion had jammed the side doors. Worse, their parachutes hung near the impact site, buried under molten aluminum and burning insulation. Every rational thought told them the aircraft was gone, that they were passengers inside a tomb falling through the sky. Yet something in the motion of the plane, the controlled banking, the faint leveling, the subtle steadiness, told them that whoever was flying hadn't given up. They huddled low, dragging wounded crewmates away from smoldering flooring as the fuselage creaked like an old ship in a storm. Every few seconds, the bomber shuddered so violently that it felt like it would split in half. No one knew the left wing had been half torn off. No one knew the tail control rod was one vibration away from snapping. But every man felt the danger in the trembling metal beneath their boots. Then came the moment that changed everything. Through the swirling smoke, the flight engineer, eyes burning, face streaked with soot, noticed something impossible. The vibrations weren't random. They were rhythmic controlled. This wasn't a dying aircraft flailing through the sky. It was a wounded one being flown by someone who understood exactly how to keep it alive. He crawled toward the forward bulkhead and banged 3 times. The crew's improvised signal for, "Are we still flying?" A second later, they heard it. 3 answering bangs from Turner. The bomber was still his. In that instant, the mood inside the fuselage changed from resignation to fierce, desperate hope. As the aircraft descended toward friendly territory, smoke thickened until men were coughing blood onto their sleeves. Oxygen had leaked out through dozens of punctures, leaving some crew members drifting in and out of consciousness. But even in the haze, they could feel the shift in G-forces as Turner lined up the approach. The plane stabilized. The violent shaking eased into a slow, predictable rumble. Someone whispered, "He's landing us! He's actually landing us!" When the belly of the bomber ground across the runway in a storm of sparks, the crew braced for the final collapse. Instead, they felt the aircraft skid, scream, and finally slide to an agonizing stop. Intact, men who moments earlier thought they'd die nameless in a flaming coffin now stared at one another in stunned silence. Handshakes turned into sobs. One crewman pressed his forehead to the blackened fuselage and whispered, "Good girl. You brought us home." It wasn't until emergency crews tore open the fuselage that the men saw what Turner had saved them from. The missing wing tip, the melted elevator, the severed fuel line held together by nothing but luck and metal tension. They climbed out into daylight, squinting through smoke, trying to comprehend how the aircraft was even in one piece. No one said it, but every man understood. They hadn't just survived a missile strike. They had survived because one pilot refused to die. One bomber refused to quit. And together, they pulled off a landing that should have been impossible. By the time Turner's crew staggered away from the wreck, coughing smoke and leaning on one another for support, the ground engineers were already circling the bomber like surgeons around a patient who had somehow walked into the hospital under his own power. The first mechanic to climb onto the wing froze mid-step. What he saw didn't make sense. Not mathematically, not structurally, not according to any engineering manual the U.S. Army Air Forces had ever written. The entire left wing tip was gone. Not damaged, gone, torn clean off, leaving jagged aluminum curled inward like a flower blasted open by dynamite. The main spar, the bone of the aircraft, was cracked in a way that should have caused total wing failure the moment Turner banked. Yet here the bomber sat, balanced on its landing gear, like it had rolled off the assembly line rather than limped home through fire. Below the wing, the fuel line was a horror show of melted metal and scorched rubber. One engineer wiped ash away with a gloved hand, only to discover that half the line had fused from heat and vibration. By any reasonable standard, the bomber should have lost fuel pressure within minutes. Instead, readings showed Turner had coaxed enough flow to keep the engine alive for nearly 400 m. Inside the tail section, a different miracle awaited. The elevator control rod, the single component responsible for keeping the aircraft's nose up or down, had been sheared nearly in half by shrapnel. Only a thin ribbon of steel, no wider than a pencil, held it together. The engineer stared at it in disbelief. This should have snapped the moment he tried to level out," one whispered. Another shook his head slowly and muttered, "He didn't land this thing. He wrestled it to the ground." As they traced the blast pattern toward the fuselage, they found the point where the missile had detonated, a ragged crater of torn aluminum, burnt insulation, and carbon scoring. The concussion alone should have buckled the internal structure, but somehow the force had been directed outward instead of inward. A quirk of angle, luck, and the bomber's stout design. One engineer crouched inside, flashlight trembling slightly, and whispered. They were sitting right next to a coffin, and it never closed. Then came the discovery that stunned even the senior inspectors on the outer skin of the right wing, where vibrations would have been the strongest during the desperate landing. They spotted a tiny line of fresh rivets, hand-hammered, uneven, unmistakably done by Turner himself during flight. At some point in the chaos, he had reached out of the cockpit with a field rivet gun and reinforcement strips, patching a seam he feared might tear open. Engineers stared at the improvised fix, then at one another. It was madness. It was genius. It was the only reason the wing hadn't folded during touchdown. Reports were filed, photos taken, measurements recorded. But every engineer who walked away from that wreck knew the truth could never be fully captured on paper. This bomber hadn't simply survived. It had defied the laws of structural fatigue, airflow, stability, and sheer physics. Turner had flown an aircraft that, by all official standards, should have disintegrated long before reaching friendly skies. One officer summed it up best as he stared at the blackened wing route. The plane shouldn't have flown. The pilot shouldn't be alive. And yet, here they both are. Word of Turner's impossible flight spread through the base faster than the smell of jet fuel after an engine test. Ground crews, who hadn't even seen the landing, showed up just to stare at the wreck, touching the torn metal like it was some kind of relic. Pilots walked around it in silence, shaking their heads, whispering things like, "How is he not dead?" and "That's not flying. That's sorcery." By noon, the Air Force Board of Inquiry arrived, clipboards in hand, brows already furrowed, ready to assign blame. Their job was simple in theory. Determine whether Turner had violated procedure, stressed the airframe beyond acceptable limits, or ignored protocol. In other words, whether he had chosen recklessness over regulation. But the moment they inspected the bomber, the mood changed. The lead investigator, a stern major known for grounding pilots over minor checklist errors, stopped talking mid-sentence the moment he reached the shattered wing route. He traced the jagged break with 2 fingers, then looked back at his team, eyes wide. "This aircraft should not be standing," he said quietly. The others nodded, some even swallowed hard. Then they reviewed Turner's flight logs. The timeline was absurd. Missile strike at altitude. Immediate structural failure, partial engine loss, control surface damage, fuel pressure collapse, a 400-mile limp home through flak lanes, storms, and hostile airspace. Every entry read like a man trying to keep death busy for just one more minute. When they questioned Turner, he didn't tell a heroic story. He didn't brag. He didn't embellish. He just sat in his chair, uniform soot-stained, left hand still trembling faintly, and explained the decision step by step, as if he'd performed routine maintenance rather than saved an entire crew from certain death. "I didn't fly her home," he said. "She decided she wasn't done yet. I just nudged her along." The room fell silent. The investigators exchanged quick glances. They could have reprimanded him for overstressing the airframe. They could have argued he should have bailed out. They could have cited a dozen regulations. Instead, the major closed the folder, tapped it once on the table, and said, "Lieutenant Turner, we're not filing anything." That was the verdict. unofficial, unwritten, legendary. After the hearing, base engineers requested access to the bomber for structural anomaly analysis. What they really wanted was to understand how a crippled aircraft had stayed airborne. They measured Turner's mid-flight rivet patches. They recreated the force distribution from the missing wing tip. They tested the stress fractures that should have collapsed the frame. Every test returned the same impossible conclusion. Turner's choices, the angles he flew, the throttle he managed, the way he compensated for asymmetric lift, had kept the bomber inside a survivable envelope by a margin of inches. A different pilot, a different decision. Even a different gust of wind would have ended in a fireball. Turner didn't return to flight status immediately. Command insisted on medical observation. But among the pilots, something had changed. Whenever Turner walked into the mess hall, conversations quieted. Men who normally joked and bragged around the table straightened up, offering nods of respect, usually reserved for aces. Within a week, the story reached other bases. Within a month, it circled the entire theater. Turner had become something rare in wartime, a living myth. Some called him the man who flew a ghost. Others said he had steel nerves and bones made of luck. But the title that stuck came from a mechanic who saw the wreck firsthand and whispered almost reverently, "He flew the unflyable." Turner's wrecked bomber sat in the hangar for weeks, cordoned off, guarded like a crime scene, studied like a miracle. Engineers crawled over it day and night, tracing the spiderweb fractures along the wing spar, cataloging burst rivets, measuring every millimeter of metal that somehow refused to tear free in the air. But the deeper they looked, the clearer one truth became. Turner had exposed a weakness they never knew existed and revealed a strength they never imagined the planes had. The first breakthrough came when structural analysts noticed an odd pattern. The damage on the surviving wing followed a stress curve nobody had predicted. The calculations were wrong, not Turner's flying. Their models said no bomber could stay airborne with that much missing lift. But Turner proved the aircraft could survive if flown with surgical precision, constant micro-corrections, perfect throttle modulation, and instinctive reading of air flow like a man who could feel the pressure in his bones. That discovery alone triggered a revision of emergency manuals across the theater. Then came the second revelation, far more shocking. The missile that hit Turner's bomber didn't just destroy part of the wing. It severed a secondary fuel conduit that should have caused an immediate explosion. Turner's decision to throttle back at the exact moment of impact likely prevented a catastrophic fire plume. Engineers replayed the math 10 times and came up with the same conclusion. His reaction didn't merely save the crew. It saved the aircraft from becoming a mid-air sun. Turner never claimed foresight. "I just did what felt right," he said. But that instinct forced the Air Force to rewrite its understanding of survivability. Within 2 months, emergency flight courses were updated. New diagrams circulated showing how to redistribute lift on crippled aircraft. Pilots practiced asymmetrical engine drills borrowed from Turner's mid-air improvisation. What was once considered unrecoverable damage suddenly became a survivable scenario, because one man had refused to die by the book. But beyond the engineering, something deeper shifted. Turner's flight became a parable. A reminder that war isn't won only by factories, strategies, or machines. It's won by individuals who refuse to accept the point where the math says it's over. Commanders cited Turner in briefings. Flight instructors invoked his name to new recruits. Mechanics wrote Turner tolerance on toolboxes when dealing with borderline airframes. And pilots, they carried his story like a talisman. Proof that courage didn't need clarity. That instinct sometimes trumped instrumentation. That a dying aircraft could be willed through the sky if the man holding the controls believed it still had one more mile left in it. Years later, long after the war, Turner returned to civilian life quietly, refusing medals, declining interviews. But his flight lived on in the systems he unknowingly redesigned, and the men he inspired to trust their hands when everything else screamed failure. Turner didn't set out to change aviation. He just refused to surrender. And because of that, one impossible flight became a manual, a legend, and a warning to every enemy who believed American planes or American pilots would ever fall according to prediction.